that for most of the other videos, if I produce any. You don't need to see me. You've seen enough of me. So be patient. You know, if you click on that, it's black. Just kind of zip through it and hopefully it comes up. Yeah, you had 2 hours to work on your homework and then stop this and look at it again. And Khan Academy, and here's another place too. Been a while since I told you about it. I did tell you about it. It's in your web page, the Math 27 front page of this. Here, I'll even show you where that is. It's all there for you. You just have to kind of hunt around for it. So you write down here, Patrick. All right, Just Math Tutor right here. It's a great resource, better, in my opinion, than Khan Academy. Better. It's not me, it's somebody else. Click again. Can you still see this, Leah? Okay. And you scroll down and wow, look at all, whoa, look at all this. Yeah, that's a ton of stuff. And you'll find topics that will work. Arithmetic, no. Calculus, no. I think it's under the algebra, no. Differential equations. Oh, here, trig. Nope, it's got a whole section on trig. So let's see, something that's real basic that we just started seeing. Let's see, proving complementary. Oh, okay. Well, that's boring. Okay, degrees. Converting radians to degrees, converting between them. All right, let's take a look and see what he has to say. Crank that up so you can hear it.
In this video, I want to talk about converting between degrees and radians. It's kind of one thing I, remember to kind of help me get going.
I'm trying to crank up my volume.
Circle of radius 1, the unit circle. Again, the idea is if you go all the way around the circle, we've gone 360 degrees. And degrees are the ones that, used to make sense to me. They still do. But radians seemed a little more foreign to me. But one thing to remember, if you remember the circumference formula, it's just 2 pi times r. But the radius, in this case, since it's the unit circle, the circle of radius 1, the radius simply is equal to 1. So the circumference is going to be 2 pi. So kind of equivalently, the distance around the circle, we say, is 2 pi radians. All right, well, that would mean that halfway around the circle, that's 180 degrees. Equivalently, that would simply be pi radians. So that's kind of my conversion formula that I remember. This is kind of the thing that I play with. Okay, so what do I mean? Let's do some specific examples. So
on the waiting room.
Converting.
Okay, I heard someone. I'm stopping.
Degrees into radians.
Shoot, hold on a second here.
Let's start here with 45 degrees.
Hold on a second. Probably someone's in the, I forgot to make somebody a co-host. Thank you.
They're in the waiting room.
Yeah, thank you. Morgan, was that Morgan? Talking to me? Who was just talking to me?
Yeah, it was me.
Okay, I'm making you co-host today. There you go.
I can't, I'm on a phone. I can't.
Okay, fine. Who was my co-host in the past? Okay, Leah, you're looking at me. You know where to find it? Watch Leah. I'm gonna. It's somewhere. You'll see it.
Oh, okay.
All it is just letting people in.
Yeah, just click it and I'll see if I can find
That's all you do. Yeah, and because I can't see it once I'm in my little camera mode, I can't see it. So it says your co-host. Do you see that invitation? Yeah.
Where do I
Right
look?
now, I don't see anybody there. There's nobody in the weight room, but
Okay.
just kind of keep an eyeball on it.
Will it just pop up at the top?
Yeah, it will. I think it says, do you see participants 21?
Yeah, there's like a button on the bottom. Okay.
Yeah, so click that and just sit there. You'll see a listing of everybody that's in there. And at the top, they'll say waiting room or they're waiting.
Okay.
If you're not sure, just holler at me. If you're not sure, holler at me.
All right.
All right, let's go back to this thing here.
So again, I basically think, well, okay, so 180 degrees, that's equivalent to pi radians. And maybe in this case, if you're good with arithmetic, maybe you can think 180 divided by what is 45. But if you're not sure about that, the way I always do it is I'll first simply make this into 1 degree. And to do that, I'll simply divide both sides by 180. So it says 1 degree is pi over 180 radians. And well, again, I don't want just 1 degree, I want 45. So I'm going to multiply both sides here by 45. And so now I just simply try to reduce this value on the right side. So 45 does go into 45 once. 45 also goes into 180 4 times. So it says 45 degrees is going to be the same thing as pi over 4 radians. And again, if you didn't know that, you could always divide top and bottom by 5, and then I think you'd be able to reduce it a little bit further, and just kind of keep breaking it down until you get to pi over 4. So let's see. Same thing with 90 degrees. I think 90 degrees is a little maybe a little more simple. So we said 180 degrees is equivalent to pi radians. Well, to make the left side into 90 degrees, we could just divide by 2 and divide by 2. So we would have 90 degrees is equal to pi over 2 radians.
Okay, so as you see, pretty darn good videos. If I had my druther, I'd create this course with only his videos and not even teach. I would organize my course and because he does a great job. But that's not how it's created. This is a support for you guys, just like Khan Academy would be a support. So now you know it's there, or you should have known it was possibly there because it was on your front page that I showed you. And there's other places too, other YouTube videos I'm sure you've kind of played around with, besides your tutoring from the tutorial center. Okay, let's eliminate that. Let's see some other kind of housekeeping things. Let me see what else we're going to do today. Stay on track. Give me a minute or two. Opening up a document for your class, my assignment schedule. That appears that today is Tuesday. Waiting for it to load. There we go. Tuesday, almost. Hey, we're almost in November. I think we only have 6 more weeks left for the semester. It seems like it. Pretty close. Tuesday. Yeah. Okay. So 4, 5, and 6. It sounds like we're doing 4, 5, and 6. That's the plan. Now I know that I sent out, I intended to give you your quiz number. It looks like 6 the last time. But I ended up being absent. So I made a decision, and it might have seemed a little confusing. I said, don't do quiz number 6. I don't think anybody did, but a couple of people were a little worried. Hey, I saw it and it shut down. What are we going to do? So I think I rescheduled it, or I just turned the time off. So it is still available, not available, but it is still something we're going to do. And it's from 4, 1, and 2. Chapter 4, section 1 and 2 is quiz number 6. And I think we'll do that today. And then Thursday, I'm looking at you don't know when your quizzes are, but I'm going to tell you right now. Thursday will be quiz number 7. It'll be on 4, 5, and 6. So today will be 4, 1, 2. Today's quiz at the end of class. And then on Thursday, I'm going to do 5 and 6, which is what I'm going to teach on today. And if that's quiz 7, looks like there'll be 3 quizzes left for the rest of the semester, because there's only 10 that I'm giving you guys. And you get 2 to throw away, two to throw away. Okay, so let me get rid of that. You don't need to see that. Done with that. Now Patrick, I think his name is Patrick on that video. I'm just going to speak some things and flip through a few pages. He talked about degrees and radians. Most of the problems, which was only 2, I think he did, left the RAD at the end of like pi over 2, RAD. I don't need that. Matter of fact, don't even put it on there. It's like double speak. What does that mean? If you don't see anything on, whether it's a number, typically when you see pi, it's a radian. But even if I said the number 5, if there's no little circle at the top, which means degree, if there's nothing on it, you have to assume it's a radian. 5 radians is not the same as 5 degrees. It is not. The only measurement that is exactly the same is 0. 0 radians, 0 degrees is the only thing that's the same. But that's boring, doesn't do anything for us. So 1 degree, 1 radian, completely different. So you don't need RAD. It's not wrong if you put RAD like pi, RAD. I'm okay with that on your homework. I'm okay with that on your group quiz. But on your exam and the little baby quizzes, they won't do RADs on there. They just won't do it. So that's one thing that I noticed in his little video. Let's see. So degrees we're probably more familiar with, aren't we? I am. I'm usually, yeah, don't speak radians very much. Yeah, degrees. Okay, so 360 degrees, a complete revolution. You probably heard that. Here's the thing. We go counterclockwise. Counterclockwise for positive angle. Sounds weird. I've always thought it was weird, taking it as a student way back when and still teaching it. So I haven't historically gone back for a while to say, why is it that positive measurements are counterclockwise where clockwise is negative measurements? It just seems backwards. I went flying this weekend. I don't own a plane. I'm not a pilot, but I went on, let's see, Sunday. Somebody took me in their little Cessna. I haven't been in a little Cessna for 40 years. It was a hoot. So, but the thing is, I noticed on his dials and everything, the way he was even calling out to whatever, the airport, he calls it a heading. We're going to call it a bearing. Word problems are coming up. Not today, but I think on Thursday, word problems. And in chapter 5 and 6. We're going to call them bearings. Our author does. He calls it in flying airplanes a heading. Now, his instruments, none of them are negative. They're not negative. They're all positive. So the way he was speaking his heading is not the way that we learn or I teach it as a bearing. It's not. That was really interesting. And he didn't have an answer. And I thought, well, that's interesting. This is a real life situation, flying an airplane, and he's giving headings. Northwest. I'm flying, north 20 degrees west or northwest 20 degrees. So when it comes to bearing problems, not today, but down the road, then I'll bring that back up. I'll bring that illustration. It was very interesting. So I said, maybe it's only nautical, when they're on ships, maybe that's a bearing rather than a heading. So positive angles, counterclockwise, I don't know why, but it is. Quadrants are all the same as algebra. Upper right corner is quadrant number 1, and then you go counterclockwise again like in algebra. That means, if I went counterclockwise like this, okay, this is quadrant 1, that's quadrant 2, just like your algebra, quadrant 3, quadrant 4. That's an ordered pair, 1, 0, just like that's X and Y, just like algebra, nothing different. The distance though, this is going to be important as you start your beginning part of your trig. The distance was always 1. It's called a unit circle, 1. Radius is 1. And then I think in 4.4, when you saw my video, I could extend that to a distance or a radius R. Radius R. If I looked at this, I could drop I think 4.2 was unit circle, 4.3 was right angle trigonometry, and 4.3 just extended it to a, like here's my radius right here. And there's a right triangle. This is one, but it could be H for a hypotenuse. You guys saw my videos, which I'm assuming you did, or a radius is R. So then all of a sudden you've got formulas that you're working with for the first 4 sections. Right angle, I mean, this is distance 1. Excuse me, right there, ordered pair. This is distance √3/2. This is distance 1/2 because of the y value. This is your y and this is your x. And you'd say, well, how do I find the length of the hypotenuse? That's baby algebra class. It's x squared plus y squared equals r squared, or hypotenuse squared. And you'll find out this is the number 1 for that triangle. So 4.4 expanded it. So it wasn't just always 1, it was something different, but you needed to use the Pythagorean theorem. You needed to use that. So if I looked at this angle right here, I'm doing just a brief review for some of these topics. If I looked at that angle, that's a radian, and notice there's no word, RAD, none, no. There's your degree equivalent, 315 degrees. These are all positive angles in here, so they're going this way. Standard position is always the positive x-axis. You would have heard me say that. This is terminal side. I'll just kind of like this, terminal side. So if I went around this way with the red pen, that would be an indication of 315 degrees, or 7π/4. And the rotation counterclockwise with the arrow touching there indicates positive. You never start it here and end with the arrow there. Never, ever. Nope. So like your group quiz, it'll be very important. All the detail I'm going to be looking for in the group quiz for sure. You know, the exam, as you know, on the little baby quizzes, is just pick the right answer and hopefully understand the material. That's all you're doing. But the group quiz, I'll be looking for detail. This right here, again, starting at the positive x-axis and going a rotation clockwise and stopping at the same terminal side, that's called a coterminal angle. And you would have seen that in 4.1, I think, 4.1. And I would say, all right, what's an angle that's coterminal to 315 degrees? And it's whatever makes up 360. That's what it turns out to be. But this one's negative. Let's see, that would have to be, let's see, 360, 45 degrees, negative. Negative 45 degrees, negative 45 degrees is an angle that's coterminal with 315 degrees. Oh, well, what's negative 45 degrees equivalent to radians? So a couple different ways of doing this. I could take 7π/4 and subtract it from 2π. I could take 7π/4 and subtract it from 2π and get a common denominator. There's 1 multiplied by 4. Oh, 8π minus 7π, π/4. All right, well, that equivalent angle is negative π/4. Negative π/4. RAD, it's not wrong. It isn't necessary. So I call this the wheel. In my face-to-face class, this is a wheel right here. And I have my students, when it's face-to-face, you guys are not, I would say classroom, you would get, if you're face-to-face, 3 parts to the exam. You would get 3 parts to the exam. One part would be no notes, no calculator, about 10 problems where you use the wheel only, this thing here only. The next part might be you get your notes, you get your calculator, and then let's see, notes and calculator. And then what's the third part? Sometimes I do a third part, a take home, when it's kind of like a big word problem or a big problem to work on, and you don't have enough time. But you guys are just taking your test. It's all multiple choice, true, false. Just pick the right answer. Yep. Lots of identities. Here's some identities. You got functions. You got 6 basic functions: sine, cosine, tangent, and then the letters of the alphabet that they are equivalent to. Y is equal to sine, x is equal to cosine, and tangent is y over x. And then all of these guys are just reciprocal: secant, cosecant, secant, and cotangent. They're just the reciprocals. So cotangent is x over y instead of y over x. Functions odd and even. You've heard that before in this course. Absolutely. Probably the third week of class, you knew algebraically, in which I'm going to test you on the final exam because it's cumulative. You knew how to figure out if a function was odd or even, or neither. Well, it's the same idea right here. Pictorially, which we're going to look at today, is the graphs of those functions. Pictorially, an even function would have a y-axis symmetry, like a parabola. You know, if it's right there, function, really nice with the y-axis right there. That particular parabola would be even. But if it's skewed, then it's not even. It would be like a neither. So these are, it turns out, these are the even functions. There's 2 of them, which it's the cosine and it's reciprocal, and all the other ones are the odd functions. And that was the definition you guys learned in the first half of the semester right here. That's an even function. The odd function would be the output would be the opposite of the original. That's the odd function. You can go back and take a look at it on your own. Let's see what else. What else? 4-2. This is right angle trigonometry. So then there's this, you know, some students remember in algebra, please excuse my dear Aunt Sally, PEMDAS. Acronym, it's an acronym, like SOHCAHTOA, sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Okay, so here's your ankle. Did I say ankle? Your angle, theta. Oh, and you're learning also your Greek letters of your alphabet too. Theta is a very common one that we use. It's probably the most popular. Popular variable in algebra, x, probably. So popular variable in trigonometry, theta. So if I want to find the cosine of this theta, cosine of the theta is the side that's adjacent divided by the side that's and you guys know the hypotenuse is always the longest side. So the adjacent is one that's connected to the angle. The opposite is the one that's directly opposite right there. So it would be, according to this, it'd be cosine would be with A over C. A over C. Like this one here. Cosine of this theta would be not the letter. Look at the side. 4 over 5. Cosine. Oh yeah, 4 over 5. And then take the reciprocal to get you the reciprocal title, which is secant. Secant. I get those mixed up sometimes. I don't anymore, but as a student, I'm always saying, well, cosecant is the reciprocal of, and you start thinking, and most of my students, like my 58 students that they have never had trig before, they think the C's, cosine, cosecant, they go together. Kind of sounds natural, but they don't. Yeah, cosine, secant. Those are the ones. So hopefully you guys have figured out how to do that, little flashcards to remind you which one is which. Tangent, cotangent is easy. That's an easy one to remember to me. You know, these guys came from the wheel. That's called exact, by the way. Root 3 over 2 is exact. Jeff, I got a calculator. Jeff, couldn't I just put that in my calculator if I knew how to work my calculator? Well, I don't know. I don't think so. I'm going to get out of this thing. Okay, cosine 30 degrees. In my video, I believe I said, be careful. You have to check your mode in your calculator before you type something in. Your mode button right here would indicate whether you're in degree or radian. If I'm going to type in a degree, you want to be in degree. I am. That's a good thing. That's good. So if I was going to type in pi over 3, if I typed it in, it'll think it's pi over 3 degrees, and that's not right. All right, so that's good. And I'm going to go second quit. I go cosine 30 degrees. I don't have to find the degree marker doing it this way. 30 degrees. All right, hit enter. And you'll say, well, okay, there it is. Calculator says it's that. That's a decimal approximation. If I did root 3 divided by 2, you're right, it would be about that. But the answers in trig, we always, with rare exceptions, want the exact answer. Exact. So if, gosh, on the exam, you're going to know that it's not decimal. You're going to know it's going to have answers with roots on it. And then you'll have to figure out how to do that, which comes from the wheel, by the way. 30 degrees. If I went back to the wheel, all I can do is just go to the wheel. Oh, here's one. 30 degrees. Cosine is the x. Well, there it is. Root 3 over 2. So there's some of those that I talked about in my lectures. Some more of those. I didn't do this one. I said I'd come back to that. This is kind of a hard one. I come back to this eventually, but not right now. A few word problems. Oh, well, this was a lot of work. I did this one in your video. This one, very similar amount of work, which is about a page worth, as this one. The work on this one and the strategy on this one, by the way, that little 5 on your page, if you took that off and took this off, take those little 5 things off. They're not supposed to be there. So it's 30 feet here, and this is, I don't know. And your job is try to find how high that is. It would require the same strategy as this one, which this one on your video was you had to come up with 2 equations, and you do substitution like you do in algebra, which was the prerequisite for this course. You do substitution. That's what I do, substitution method, not elimination. And so there was a lot of work on this to get to a final answer that I've got there, which that is supposed to be the distance right here that I was looking for. Okay, did that one. Okay, 4.4, more the same. See, there's a negative 11 pi over 6. Yeah, I did it in blue. It got me in a quadrant number 1. And it looks like that's going to be a reference angle. That's the other thing you guys learn. Reference angles are acute, A-C-U-T-E, acute angles in your geometry, your sophomore geometry class. You would need to remember that it's an angle that's less than 90 degrees, less than pi over 2, and greater than 0. That's an acute angle. So all the red angles right here, and it has to be positive for a reference, though, on top of it. Positive, 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 all acute. And this is kind of a, I guess, exact. That would be exact answer at the end without putting in a calculator and get a decimal approximation. So it looks like I did that one. Okay, there you go. So that was a review of 4 sections worth. So now today is going to be graphing. Let's see, we're going to graph, pretty sure, sine and cosine for sure. I'll use my technology. I'm going to do it by hand to start off with, but use my technology. And let's see, probably tangent, cotangent, I think. 4.6. Let's see. 4.6. Yeah, other graphs. Oh, it's all the other ones too. It's all the graphs. There you go. Secant, cosecant. Okay, so today is all about graphing. All about graphing. All right, so here we go.
Quick question. I don't know if it's inappropriate, but are we having a quiz today or?
Yes.
All right.
At the end, 4142. 4142. Yes. So I'm going to go to the wheel and fill in a table of values. I'm going to go to the wheel back and forth, back and forth. So this is, I'm going to fill in all the angles. I guess I'll do it in degrees instead of radians for right now. I'll do the degree. So if I start at 0 degrees, okay, so the X values right here are going to be the degrees and the Y values are the outputs. So this is the inputs. Y is the outputs. Inputs are angles. Outputs are real, exact numbers. So the real nice ones are right off the wheel, like 0 degrees, 30 degrees, 60 degrees, 45 degrees. So all the angles that I see on this wheel, I'm just going to list them all down. See, 30, 0, 30, 45, 60, 90, 120, 100. I'm just going to write them all down. Okay, after 90, then I'm over here. Oh, 120, 135, 150. 120, 135, and 150. The distance right here is 30 degrees. The distance from 90 to 135 is 45 degrees. The distance between this marker and there's 30. So a lot of angular measurement stuff that you guys can look for patterns. Okay, after 150, 180 right here. 180. 210, 225, 240, 210, 225, and 240. Now, if this was a group quiz and you left it like this, I would take points off because you didn't put a degree marker on. Anytime you drop off a degree and it's supposed to be a degree, I'm going to think, oh, they're talking radians all of a sudden. So I'm pretty picky about that. There's a lot of things that I'm picky about. That's why it's sloppy. I call that, oh, make sure you don't forget. Somebody's going to forget and you're going to get points taken off. 40, 270, 300, 270 degrees, 300 degrees, 315, 330. And now I've made a full revolution. I'm back where I started from. So I'm going to stop right there. So these are angles, A-N-G-L-E, angles. And now if I put the values, what am I looking at? I want cosine. Since I'm focusing on cosine on the wheel, the ordered pairs are X's and Y's. The cosine are just the X values. So I'm just going to list next to the angle 0 degrees, 1 is the X value. 1. You might say, this is confusing, Jeff. X, hold it. What are you talking about? Okay, so you guys are big boys and girls. You guys are pre-calculus students. It's just a change of variables. You can figure this out. If you thought about f of x like this, That's function notation. That's a fancy way of saying the letter y. What I'm doing is I'm graphing cosine x. So y is the output, x is the input. The input is an angle from the wheel. That's what all I'm saying. And the output is whatever the first digits are in your ordered pair. So let's see, 30 degrees. First one, √3/2. There's a pattern here too, by the way. √3, √2, √1 over 2, √0 over 2, which is 0. Let's see, √3/2, √2/2, 1/2, 0. -1/2, negative. Okay, these are all negative, 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 negative. That's the word negative, -1. So -1/2, negative √2/2, -1/2, negative √2/2. Keep going. Third quadrant, negative √3. Okay, so I'm back around again. Negative √3/2. Negative √2/2. -1/2 again. Okay, 270 is right here. The x value is 0. Yeah, cosine of 270 is 0. Okay, now we're back over here. +1/2, positive and positive, and back to 1. Okay, so 1/2, √2/2, 1/2, √2/2, and back to 1. So I'm going to, along the x-axis, I'll do this first. Along the x-axis, I'm going to list from smaller to bigger. So 0 degrees is right here, 0 degrees. All the way to 360 degrees. So let's say way over here is 360 degrees. Okay, halfway in between is 180. Halfway between here, halfway between this, oh, that's 90 degrees. Halfway in between here would be halfway, oh, it's this one here. See, halfway between. If you look back on the wheel, you're looking at the places where it's the axes, the x-axis and the y-axis, the angles that make that happen. So you're over here at 270. Okay, now the next thing I'm going to do is take half of that again in between. So these are 45-degree markers. So 45 degrees. This one's 135. This one I think is 215. Let's see if that's right. 225. And then 315. Okay, 315. And then the other ones, and I'm not going to squeeze in the numbers. I'm just going to put the other little tick marks, like for 30. Now, halfway between 0 and 45 is 22.5. You're not going to put 30 right there smack dab in the middle. So if this is 22.5, I need to come a little closer into 45. So like right here, ish, that's 30. And in like manner, 60 degrees is not smack dab in the middle. It's not. If you add these together, you get 135 divided by 2 is not 60. So it's over, it's a little closer over here. So each one of these little tick marks kind of hug the middle a little bit. That and that, like that and that, and like that and that. Okay. Now this is a half. Of course that's a half. Of course, this is -1/2. And you can see the values of the y values. The y values are running between 1, 0, negative numbers. So -1 to 1. They're not changing. So that's why on here, I've already got it listed for you between -1 and 1. So I'm going to plot dots. I'm going to plot as many values. These are like ordered pairs here. Plot as many of these as I see in purple. I'll do it in purple. Well, you probably don't see the difference on yours, but it's going to be a felt pen color, not blue. 0, 1. Okay, so it's right here. Check. I'll check them off as I go. Check. Okay, 30 degrees, √3/2. Okay, 30 degrees. Okay, 30 degrees is right here. Now, √3/2, you can get a decimal approximation to see what the value is. Let's see, second √3 divided by 2. 0.86, a little bigger than 0.8. So right here is not halfway. That's 0.75. So a little about ish right here. Okay, 45 degrees. Okay, √2/2. 45 degrees. √2/2. Okay, so second square root 2 divided by 2. Okay, about 0.7. So a little lower. So a little lower. Okay, 60 degrees. 60 degrees actually turns out to be a half right here. So right here, the half. Okay, 90 degrees. So I've checked that one, checked that one, checked. Okay, now I'm doing that one. 90 and 0. So right here. Okay, 120 degrees. Up, we're down to -1/2. So 120, -1/2. So it's right about here. 135. It's similar over here. It just goes up, well, down, down a little bit more. 135-ish right here. And then whatever this is, okay, check. A little bit more, a little bit more. So that eventually 180, oh, we're down to -1. 180 is right here. And eventually I'm going to connect all the dots with a curve, with a smooth curve. Okay, so I did that one. The next one is going to be this one, 210. Okay, we're back to this. This is about 0.8 something. √3/2 is about 0.86, almost 0.9. Negative though. So here, oh, it's like right over here. There's a little symmetry thing going on. Oh, and right here, 225 degrees would be the same values coming straight across over here. This value right here, which I believe was -1/2. So right here, yeah, 240 -1/2. 240 -1/2. All right, well, let's see, 240 -1/2, right there. 270 is 0. And again, a half. And then 314. And then what you do is you connect the dots. So when I connect the dots, it looks something like so it's one period of the cosine function. I say one period. A period would be a complete revolution, a complete cycle. You know, I've gone from 0 to 360. So if I went from 360 to 720, it would just be another copy of this, but matched over here. And I can always go backwards. Now backwards would be over here. Wouldn't this be, these are all the negative values over here. negative angles. So from 0 to negative 360 would just be another copy of this. So they call it periodic. They're periodic functions. If I were to graph this with my calculator, you have to decide which mode you want to graph it in. Sometimes the author gives you everything in radians. They'll have all the values like pi's over 4s and things like that. It's easy to forget and plug what I'm going to do right now and forget to change it to radian mode. Yep. So just remember, always check the mode. Okay, I'm in degrees and I'm going to plug in degrees. Got it. Okay, I'm going to go into graph this right here. Cosine x. Yeah, they don't use theta. You might say, well, what's that right there, Jeff? This little circle with a slash through it. Well, it's certainly not theta. I'll just tell you that. It's not theta. So we're going to graph it in what's called function notation, which is the variable x. Now, the next thing that I'm going to do is change the viewing screen. You don't want to do zoom standard. You don't want to do that. Sometimes zoom trig works okay, not all the time. Previous problems, the first half of the semester, I was doing zoom standard a lot, at least to begin with, exclusively. Zoom standard, you don't want to do that. Zoom trig, I'm not going to do it, but sometimes that works okay, and sometimes it doesn't. So all I'm going to do is change my viewing screen. See, I'm going to change all these numbers so it mirrors or matches up from 0 to 360. I want to match up from 0 to 360 degrees. 0 degrees, 360 degrees, and then scaling, I don't know, pick a scale. I'm going to pick every 45 degrees. I can't pick something that's always going to give me these tick marks, but I can 45, 90, 130, every 45 degrees. I'm going to make that 45 degrees just because of a tick mark. That's all it is. Not that important. Okay, y minimum is -1, y maximum is 1, scaling a half. Let's go a half. 0.5. And now I'll keep my fingers crossed and I'll hit graph. See what I get. Pretty nice picture. It looks like that. Now this one, it's not a square. It's a rectangle. The distance here is not the same distance as here. This one's longer. So period of a function is the distance and length and time it takes for it to repeat. The period of a function is 360 or 2 pi. Okay, the domain of the function is all real numbers, unless you see, you guys remember this, I hope you do. My Math 25 remember it because they're always talking this stuff, but you've done Math 25 material already the first half of the semester. Domain of any function is all real numbers unless you see fractions, roots, logarithms, or inverse trig functions. I've said that a number of times for you guys, but we don't have any inverse trig functions. Okay, so that's not inverse trig function. So the domain is all real numbers. That's what it's saying. The domain is all real numbers, but the range is the low to high, and it's only from -1 to 1. Brackets mean you include them. These are standard forms. Those are standard forms. Oh. Oh, I can't get it in. All right, fine. I'll just not do that. Okay, not do that part. All right, so if I gave you this, which I'm bound to give you something like this on the test, number 3, where I would ask, because it comes back again, what's the transformation? List in order the transformations, because we can do the same thing with these functions as well. And I'll just remind you what you're listing. They're always got to be in order. Left to right is always first. And then reflect x-axis is maybe number 2. And then vertical shrink stretch would be number 3. Number 2 and 3 could be interchanged. And the very last thing is the up and down, which I just kind of whited out the up and down part right there. So the first part would be a move right pi over 2. That would be your, this would be number 1, right pi over 2. Number 2 focuses on these guys. I'll do the negative first. That's the reflect. Reflect. If you just say reflect on the group quiz, not good enough. You have to tell me the axes. You have to. So you have to say x-axis. X-axis. Yeah, we never did y-axis. I said we're not going to do those. So still not going to do them. And then finally, number 3. Okay, the half is a shrink. Anything that's smaller than 1 is a shrink. And it's got, you got to say vertical, because if you don't, you're not going to get full credit. So it would be a vertical shrink. Vertical, shrink. And if you say by a half, I'm okay with that. You can leave it off, but you can say by a half. Okay. Some other things here. So you can see vertical stretch or shrink is up there. Okay, amplitude is something new. Amplitude says, what's the distance? Distance is always positive from the center or the middle of the graph to the up and down. And it's always going to be the same distance. Okay, here's the center of the graph right here. What's the distance to the top? What's the distance to the bottom? The amplitude is 1 on this one. The amplitude here is a half. The amplitude, AMP, equals the absolute value of negative a half, because you'll see it's absolute value, but it's always positive. So the amplitude is 1/2. That means if you were going to graph this one on paper without the aid of a calculator, sometimes I've asked this, especially since on the group quiz, for instance, draw me 2 periods, so that if and you got to give me the window feature in your calculator like this. What would the window feature in the calculator need to be so that I get 2 periods of this picture that I just drew right here? That's only 1 period. So, and I would ask you for that. And so, and then draw me the picture as well. So yeah, you can do it with your calculator, but I would want to know that if I put in, and there's only one answer, by the way, the one answer from the X min to the X max. Well, one, there isn't one. There's infinitely many answers. Okay, what I would do is go from 0 to 360 like I just did there. And then I would add another 360, so 720. I would change this to 720 because every 360 for right now is another copy. And the Y values are not going to change. They're going to stay as -1 to 1. So in the 45 degree, that marker is not going to be a big deal to me. The tick marks are not the big deal. It's it turns out the X values. What's the min? What's the max? If I graph this right now, you'll see it should be 2 pictures complete, and it touches the bottom and the top of the viewing screen. That's what I want. Yeah, I'm not giving you a test where it's no notes, no calculator, or no notes. Let's say no notes. Somehow give me a decent graph on paper, basically draw it on paper. Yeah, you're just going to have 24 hours to do your test and you pick the right answer. But on the group quiz, I will be picky. Okay, domain, range. Okay, these endpoints, these will be helpful to know. I'll come back to those. This is in terms of radians and period. Okay, period. So those two are going to be helpful. Period is 2 pi divided by b. See, the b is the numerical coefficient in front of the x. That's going to help you. And what that means is how long does it take to repeat itself? The period means how long is it? Okay, what's my b right here? Oops, what's my b? 1. So the period would be 2 pi divided by 1, which is 2 pi. It repeats itself after 2 pi all over again. So then you go from 2 pi to 4 pi, 4 pi to 6 pi. That's 3 periods. Yeah, 3 periods. Okay, so this would be a picture like I did for you, except here's your negative region, here's your positive region. Here's a sine, which kind of looks like that. These look the same. This is just shifted. Sine and cosine are cofunctions. Remember that? Means that they're shifted by 90 degrees. Cofunctions, I think that was 4.2 or 3 that you're responsible for knowing. The cofunction identities. Yeah, it's a shift. If you think about where, let's say that value right here is, you can think of that's been pulled over here to the right by pi over 2. See, that's 90 degrees. So it's like taking this picture and moving it this way, and that's the sine, or vice versa. So if I were wanting to draw this, then I would say that is g of x. In your calculator, let's say you want to demonstrate in your calculator, equals sine x instead of theta. This is your x minimum. This is your x maximum right there. And it's as low as -1, as high as +1. So I go over here and do y equals sine x. Window. I'm going to go, okay, now we're radians. Oh, we're radians. Got to check the mode. Yeah, I'm in degree. Change it over there to radians. Okay, now I'm good. I can do the radians now. Window in radians, -2 pi. Now the pi button is that up arrow or that little caret right there. That's the pi button. The positive 2. Okay, again, I'm just hitting this pi button right there and hit enter, and it converts it into, it looks like a decimal approximation, but you can see the dot forever. So it's going on forever. Okay, scaling. Okay, now that's degrees, as you were thinking. I want it in radians. So how about pi over 4 or pi over 2? I'll do pi over 4. So pi divided by 4, tick marks. And -1 to 1 is good. So let's see, graph. I want it to look like this. Yep, looks pretty good. Okay, I'm gonna do a few of these. I think I might do this on separate pieces of paper instead of these funny, let's see, do I want to do that? Funny graphs. Yeah, just because when I look at pi over 2 and I'm trying to get a bearing as to what to do it. I'm going to show you how to graph this, by the way. I'm going to show you some ideas about graphing it. Remember this? On the test, I'll ask you on most of these problems, I'll say, problem number 1, multiple choice. What's the period? period's 2 pi over b for sine or cosine. Problem number 1, right? Well, this one. This one here, what's the period? Is 2 a? Is 2 the lowercase a on this one? Is 2 lowercase b? And there's lowercase c and lowercase d. That's over here. Lowercase a, lowercase b is the numerical coefficient in front of the variable x. Lowercase c is the thing over there, separated by addition and subtraction sign. And lowercase d is way out in outer space, which moves the picture up and down, up and down. See, so like this one here, there's no, well, there is an a. A is 1. A equals 1. B equals 2, C equals 0, D equals 0. I might even ask that on a multiple choice test. Tell me what the A, B, C, and D are, and I got a variety of answers I can get from you guys. So if I said, what's the period? That's 2 pi divided by B. Oh, 2 pi divided by 2 is pi. So that's how long it takes to repeat itself. And since it's a cosine, I know it's going to have this behavior right here. Cosine has this behavior. It doesn't have, they start looking the same. I'll show you how I'll start. For cosine, I always start at the top and end at the top and then halfway here. So this would be a basic cosine to begin with, unless there's a reflection. If there's a reflection, then I know it's going to be upside down. I just know that. There's 5 key, count them 5, 1, 2, 3, 4, 5. 5 key points to plot, always. And I might even ask you on the multiple choice, how do I do that? I might just say true or false. There's 3 key points to plot, and it's false. I mean, it's 5. I might ask you, what are the 5 key points on a particular problem? What are the endpoints? These are the endpoints right here. Anyway, 5 key points. I'll show you how to do that. Yeah, I'll do this right now. Okay, so if I know that, oh, I know, over here. I'm going to use this now. What I just circled in purple. So I'm going to circle in purple right here. The endpoints. This is the left endpoint. This is the left. This is the shift. This is what's called the phase shift, how far left and right you're going to go. And this is the right endpoint. So for me, the way I do it, your textbook does it slightly different, and you can follow along how they do it. They do 5 key points as well. They do 5 key points. They just do it slightly different. I'm going to start with the left, and then I'll do the right. That's 2 out of the 5. Then you just got 3 more to find. And it's very symmetric, very easy after this. So the key is going to be finding the left and the right first. So I'll go down here, left. You take the 2. You take the bx minus c and set that equal to 0. Okay, bx minus c is always found inside the parentheses, always found inside the parentheses. There's just no c here. So I take everything inside the parentheses and set it equal to 0. Okay, 2x, set that equal to 0, and solve for x. Oh, x equals 0. Okay, that's your first left endpoint. That's a left endpoint. Okay, right. Find the right. Again, you go b, x, subtract c, but this time you go all the way to 2 pi. So my bx minus c is still the same 2x. So you're going to go 2x is equal to 2 pi, solve for x, and you get x is equal to, oh, the 2's will cancel, pi. The distance between the left and the right, the distance is equal to the period. It has to be period. From 0 to pi is pi. Check. That's a way of confirming. Check. Another idea could have been, hey, find your left. This works. You want a left and a right. Hey, find your left first and then add a period. It'll work every single time. So I found 0 and then I added this period. I found 0 here, then I added this period, and that gets me to the right. I don't care how you do it, just either find left and right, and then you're done, and you can check it off. Hey, that's the period in between, sure. Or find the left, and then add a period, a pi, and that'll be your right. X equals 0 plus pi. So right now, I'm going in here, right there. Right here, right here, right here. Now my amplitude, let's do this over here. The amplitude is the A, the absolute value of A, which is the absolute value of 1, which is 1. So and this is why I probably wanted to do a different graph because the amplitude is 1. From the middle, which is always going to be the x-axis. Okay, hint, hint, hint. The x-axis is always going to be the middle for everything unless there's an extra piece on the outside of the function that shifts it up or down. Our book doesn't have a lot of those choices for homework. So for me to ask you to graph one when there's only about 3 or 4 that they give me to give you, I probably won't ask you to graph it. But I'd ask you to do the phase shifting to describe to me your transformations. I do that, but not to graph it. So if the period is 1, you go up to here and right down to there. This is a very small region to graph. Here, look at, zoom in, makes it a little bigger. Sorry. I know, a long time ago when I took my trig, my instructor said, hey, draw a little box, draw a little kind of an imaginary box, because that's what my curve has got to be fitting inside the box. It's like the viewing screen of the calculator. That's my viewing screen of the calculator. All right, Jeff, then what? I need 5 points, need 5, I call them key points. Okay, here's 1 and here's 2. Now, here's an idea. You could do it, but there is a pattern. Here's my X, here's my Y. Okay, X is going to be 0 radians, and another one is going to be pi radians. If you plug in 0 to here, okay, let's see, 2 times 0 is 0. What's cosine 0? On the wheel, cosine 0. I wish I had a way of testing you guys memorizing this stuff, because face to face, you would have to. I say that only because I don't know who you're going to take for your 1A. I don't know. I'm not doing 1A. I'm retiring. I'm going to make my life easy. I'm not going to do a 1A. It's a lot of work to do online. Your choices for instructors. There are instructors, I'm telling you right now, that will say no notes, no calculator. They're going to proctor your exam. How are they going to do it? I don't know. Some of the instructors are getting permission to go back on campus specifically for test days only. They're getting approval for that during this COVID thing. And I don't know who's doing that. And if they do that, there's some instructors that say, okay, we do that. No notes, no calculator. That's just the way they teach. So I prepare my students in a pre-calc class for that by getting them to memorize a lot of stuff. I'm not asking you to do that. I want you to know how to find this stuff and know that in preparation, it should be something that's, how do I say it? If I said 4 times 4, you say 16. I did that right. 16. You didn't have to think. If I said cosine of 30 degrees, you should go, okay, I can draw a picture and it takes me a little bit longer. No calculator. Aha, because calculator is not going to give you an answer. It's going to give you a decimal. Root 3 over 2. Because the time you're going to have on your trig part or the other stuff in your 1A class, you're going to be limited. Here's the other thing too. Some of the instructors, they don't say, oh, I'll give you 24 hours. No, they'll say, we're in class. Our class is like here, 2 hours and 20 minutes is instruction, or 2 hours and 40 minutes is instruction. That's all you get. That's it. And you have to be face to face. So just preparing you, just, okay. It's enough of me saying that. It's because I care about you guys. I care about you guys doing your best. And
well, you gave us the ones that are important. At least one of them. Cosine 30
right.
is important for a reason. Yeah.
Okay. So here, okay. So cosine 30, all the ones that you should have memorized or in your brain.
Cosine 30 and sine 60 are the good ones.
Cosine 40. Oh, you mean for this problem?
Well, they're not specifically for that. Just there's like easy ones to memorize that help you do the entire wheel from
Yes.
just a few of them.
I would agree with that. And the wheel is created. If you can create the first quadrant, if you can memorize the first quadrant, the second, third, and fourth are copies of that. You just have to decide, is it negative or positive, you know, on the axes, you know, is the X is negative, the X is positive. There's ways of doing it. You guys can figure that out. You're smart people. You are. You're taking a monster one class here, and you can do it. I know you can. So if I put in 0, cosine of 0 is 1. Look on the wheel, it's 1. So if I do it like here, cosine of 0 is 1. If I put in pi, okay, cosine of 2 pi. Cosine of 2 pi, cosine of 2 pi, cosine of 2 pi right there is 1. 360 is the same as 2 pi. Oh, it's 1. Okay, there's 2 critical points. Halfway in between. Okay, halfway in between is pi. This is how I do my 5 key numbers. I just do the one on the first and the one on the end and take the average of those two, no matter what they are. You guys know how to do averages? My stat class doesn't know how to do that. Okay, average, A-V-E-R-A-G-E of the first and plus the last divided by 2. That's called the average. Okay, our first is 0 plus pi divided by 2 is pi over 2. Okay, so if I put in pi over 2 right here, 2 times pi over 2, the 2's cancel, it's pi. Cosine of pi. Boy, it's been a while since I've done this. Cosine of pi. Where's that wheel? Where's that wheel?
That's
Cosine.
the X value at pi radians.
Okay, pi right here. Cosine of pi. Oh, it's -1. -1. I go -1 here. So -1, this is 1, and this is 1. So halfway right here is -1. All right, put a dot right there. All right, now halfway between these guys right here, halfway between there and halfway between there. Oh, well, shoot. Okay, I'm going to go 0 plus pi over 2 divided by 2, which is pi over 2 divided by 2, which is pi over 2 times half. Sorry.
Pi over 4.
Yeah, pi over 4. Oh, pi over 4. So I go pi over 4. And this one turns out to be 3 pi over 4. 3 pi over 4. So pi over 4, 3 pi over 4. Pi over 4, 3 pi over 4. Okay, I'm going to go over here to my wheel again. Oh, we're still at cosine. Pi over 4, root 2 over 2. 3 pi over 4. negative root 2 over 2. So this is root 2 over 2, negative root 2 over 2. Let's see if I did this right here. That's not right. Oh yeah, that's right, but it's not right here. I apologize. Yeah, if I put pi over 4 here, cosine of 2 times pi over 4, that equals cosine of pi over 2. Oh, okay, cosine of pi over 2. Okay, that's going to be 0. In like manner, if I put 3 pi over 4 here instead, if I go cosine of 2 times 3 pi over 4, okay, 3 pi over 2, so cosine of 3 pi over 2, look on the wheel on that value right there, not these guys, that one. Then I end up with 0 again. Yeah, 0 again. And that's what I'd hoped. Okay, so that's not pi over 4. Halfway in between here is like right there. And right there. And so you go like this. Curve donut. If you connect the dots on your group quiz and you make it look like a V, like an absolute value V, you did a crummy job. Got to put a little curve to it. Curve to it. Put a little curve to it. Now this is a small window, but curve to it. And what if I wanted 2 periods? So let's say this one here, I want 2 periods. 2 periods. Well, then I just extend it out another period. Like, what is that? Pi? Okay, so I'm like, and that looks like that. I mean, just another copy. Like this. I'm going to put it here, put it there, put it there, put it there, and put it there. And in your calculator, if you did, you want to graph this right here in your calculator. And I said, what's the window feature? Window. And, say, okay, window feature. Okay, that's not the graphing window, but window. You go X min. You would say, well, X min, the one I want Jeff to look at is this one here. So X min is 0. X max for 2 periods would be up to 2 pi. And X SCL is, gosh, I guess pi over 2. Pi over 2. That's not, the scalar is not as important as the min and max for me. And then you go Y min. Okay, in the little imaginary box, it's -1. And X max is 1. And the scalar, I don't care. I don't care about the scaling. So if I asked you on the test, multiple choice test, I might give you 4 choices of what the window would be, and you have to pick the right one.
So on the bottom, it's Y min and Y max, right?
Well, thank you. I think I said it. I wrote it wrong. So thank you for that correction. Absolutely. Yes, yes, yes. Y. Yeah, thanks for that correction. Okay. Do something a little more complicated, maybe with a sine. Okay, I'm going to tell you right now, I'm not going to have you graph any of these. So these last 2 right here, just because what I can do is ask you, what's the transformation? Not on this one here. That's a down 3. This is a down 3, but I'm not going to ask you to graph it. It's pretty hard to do by hand. So no. I don't think I gave you any homework on those either. All right, the reason why I'm going to pick this one, I guess, it's not that hard. It's just I see a negative and a 3. I see a negative, and it's a sign. And then I'll do maybe something that looks like, yeah, this kind of looks crazy right here. I'll do this one. And after I do those three, then I'll go on to the tangent and cotangent. I'm going to do this on a separate piece of paper just because I can make my own scaling and make it look a little bigger. Okay, so let's ask the question amplitude. The amplitude is the absolute value of -3, which is 3, period. 2 pi divided by b every time. 2 pi divided by, okay, the b is the numerical coefficient in front of the x. The numerical coefficient in front of the x, it's 1. So 2 pi. Left, the way I do it, I'm going to find 5 key points. I'm going to find the left first, which is bx minus c is set equal to 0 every time. And my bx is just plain old x. So it's boring. This one here is more interesting right here when I do this. That's really interesting one. A lot more to that one. The reason why I'm doing this one is because it's stretched. It's a vertical stretch and there's a reflection. So x equals 0, bx minus c is equal to 0, sure. And then right, bx subtract c is equal to 2 pi every time, 2 pi. These are radians that I'm doing. So what's inside the parentheses is plain old x. That's it. X is equal to 2 pi. So that's my left. That's my right. You can do this, x and y. Your y is the output. So x is going to be 0 radians and then 2 pi radians, halfway in between. Halfway in between, I think you can probably guess this one. Halfway in between is pi. So pi here. Halfway in between, take the average here, it's pi over 2. Halfway in between here is 3 pi over 2. And then you can replace each one of these with the variable up here. And if you want to use your technology to find those out on your exam, be my guest, not a problem. Otherwise, if you use the wheel, let's see, 0, sine of 0 is 0. Sine of 2 pi is 0. Sine of pi is 0. Okay, pi over 2. Now, the reason why I can do those so fast is I've done them so often, and it's a sine. So if I looked at the wheel to confirm, okay, sines are the y values. Okay, so I said 0 is 0. Okay, and over here is 0. But at pi over 2, it's going to be 1. So sine of pi over 2 right here. Remember, I take the pi over 2 and plug it in. Here it is. I plug it in over there. So a little more complicated. You go y. So this one here, y equals -3 sine of pi over 2. Y equals -3 sine of pi over 2 is 1. -3. Okay, this one here. If I go y equals -3, 3 pi over 2, -9. My mistake. Sorry. Apologize. I'm putting in 3 pi over 2 for my function right here, 3 pi over 2. So -3 sine 3 pi over 2. Okay, that's -3 times. Okay, 3 pi over 2 on the wheel. Right there. Sine is -1. -1. So 3. start at 0, go to 2 pi. So start at 0, and then 2 pi is maybe over here. I need to go to pi, pi over 2, 3 pi over 2. Now look at the y values. Okay, the range on this is going to be, okay, D for domain is all real numbers anyway. It's always all real numbers. R for range for this one, it's the amplitude in this case, so -3 to 3, bracket. So 1, 2, 3, 1, 2, 3. So I'm going to make my little box like this. This is 1 period. 1 period. Now I'll put my dots in the appropriate place. Okay, 0, 0. 2 pi, 0. Okay, right here. Oh, pi, 0. Now halfway in between pi over 2 has got to go down here to -3. And halfway again, oh, got to go +3 up here. And connect the dots. Don't connect the dots with the straight line. You got to give me some kind of a curvy, because it turns. And that looks to me, because I've done this a number of times, but it looks like upside down. Upside down. See if it starts at the origin right here. It starts at the origin. Come on. My focus. There it is. Okay. It goes up and then down. This one here went down and then up. What else about this? Say something else about that. I forgot. And how many periods is that? 1. How many periods here? You should be able to recognize the number of periods. That would be also another multiple choice, question. How many periods do you see? There, I see 2. There's 1. There's 2. I see 1 period here. Trying to find some other ones that are interesting. Yeah, the rest of it, you can see how he's developing right here, his 5 key points right here. It's a lot of work. See, 5 key points. It's a lot of work. You can do it his way. It's up to you. A lot of work. I can't see anything interesting to show you for the graph. Let's do this hard one. This one. That one. Okay, amplitude 3, absolute value 3 is 3. What do we? Oh, period. Period would be 2 pi divided by b, always b. 2 pi divided by 2. This is your b. This is your c. And this is your A. Oh, this would be interesting because it's always going to be a mistake here. Okay, so A. If I asked you what's A equal, B equal, C equal, I'm going to tell you right now, half of you are going to answer C incorrectly. You're going to give me the wrong sign. A is 3. That's not an issue right there. And B is a 2. That's easy. But it looks like C is negative pi over 3 because there always has to be a negative sitting there for you to decide what your C is, sign and everything. So it's always the opposite sign. It's always, remember the direction, always opposite direction. For the shift left and right, it's always opposite. So be careful that I could ask a multiple choice question. What's your A, what's your B, what's your C? And then change up all the signs. They're all the right numbers, but the wrong signs. Except that's the right answer there. Okay, here it's pi. Left. Okay, left is the, all of this, more interesting, 2x plus pi over 3 set equal to 0. And then the right, again, all of it set equal to 2 pi. And then solve for x. So move this over, you get 2x is equal to minus pi over 3. X is equal to, this will end up being minus pi over 6, because you're going to multiply both sides by a half to get rid of the 2. Multiply by a half, which is the same as dividing by 2. Okay, 2x is equal to 2 pi subtract 3, and then x ultimately is, that was weird, 2 pi subtract pi over 3. A little quick and excited about this. 2 pi subtract pi over 3 divided by 2. Oh, that's a mess. I'll show you something here. That's the algebra. I mean, you'd have to get a common denominator and eventually divide by 2 and multiply by a half. That's the easy one. That's kind of a messy one. I'm not done with that one. Here's an idea. I can take that and add a period. I said that before about 20 minutes ago. I can take this and add one of those because it'll be exactly what that is. I could take negative pi over 6 and add a period. Period's pi. This is your right. So if you did the algebra all on this, you're supposed to get 5 pi over 6 when you're done. So you can do either way. I don't care. But this will be your right, and this will be your left. And the distance between these two will be pi. 6 pi's over 6's. That's what it'll be. All right, so let's make my little box here, here. All right, now I have to go from negative pi over 6 to 5 pi over 6. It's a little tricky, so I'm going to go over here, negative pi over 6. So that's 1 pi over 6. I have to go all the way out to 5 pi over 6. 1, 2 pi's over 6's, 3 pi's over 6's, 4 pi over 6, 5 pi over 6. Okay, this is 5 pi over 6. 1, 2, 3, 4, 5. Okay, that's my end point right there. And then my amplitude is 3. The amplitude up here is 3. So I have to go as high as 3. 1, 2, 3. As low as negative 3. 1, 2, 3. And my little box starts. This is my boundary for my first period. My little box goes like this. It makes a turn. Continues down here, goes across at 3, and comes down like that. Okay, this is going to be one period. Now there is a pattern to sines and cosines. There is. My question might be, is there a reflection? Is there a reflection that I have to be concerned about? Reflection on this one. No, there's no negative. And I've got the wrong amplitude. Okay. Oh, there it is right there. Wrong problem. I got the right amplitude. Is there a reflection on this one? No, there's no negative. Okay. So if there's no negative, the behavior of a cosine will always look like this. If there's no negative, it'll always be high and end high. So that'll always be reaching the upper edge of the amplitude. So will that. And then halfway in between will always be the lower bound of the amplitude every time. And halfway between will always be x-intercepts, guaranteed. Unless there's a shift up or down, which I'm not asking you to do that for the graphing anyway. So guaranteed for this one, it starts high, ends high. Now, if you want to confirm that, all you have to do is just take negative pi over 6 and do the work right here. Do the work. Put in negative, not that one. That was weird. Put a negative pi over 6 right here and work it out and tell me if you end up getting 3. That's what I'm claiming. If you put in negative pi over 6 into the function right here, you're going to get 3. I challenge you to do that on your own. And if you went halfway between here, oh, this gets a little challenging. Watch this. Halfway between. This is a tick mark as well. That's a tick mark as well. So to go from here to that's supposed to be pi. So I'm jumping 6 of these. 1, 2, 3, 4, 5, 6. Yeah. That works. So halfway in between, I'm just going to kind of point my fingers halfway in between here, here. Oh, right there. Right there. Whatever that is. That's going to be low right there. What is that marker's value? 2 pi's over 6's. Or if you reduce it, it would be pi over 3, but 2 pi over 6. Now, what I claim is halfway in between is going to be the x-intercept now. Halfway between these two right here. That means right here, whatever right here is, that's the hard one. I just have to take the average to find that marker is a y-intercept, and like manner here, halfway in between. So what is that? Halfway in between, right there. That takes negative pi over 6 and add 2 pi over 6 and divide that by 2. You're taking those two endpoints, these two right here, and take the average to get what's in the middle. So that's pi over 6 divided by 2, which is the same as pi over 6 times a half, which is pi over 12. This marker, which depending on the questions I ask on the group quiz, I'd say place all your key markers for your 5 key points. I got to see them on your number line. So I placed 1, 2, 3. I need that one, if that's what I'm asking for, which it is on the group quiz. And that's pi over 12. And I need that one too. So I'm going to take 2 pi over 6 plus 5 pi over 6 and take the average. 2 pi over 6 and add 5 pi over 6. That was weird. Uh, 7 pi over 6, 7 pi over 6 divided by 2, which leads me to 7 pi's over 12. So this is 7 pi's over 12. And then you connect, this is one period. This is one period, one. Asking you for 2 periods of this. The markers are challenging. It takes a while to do the markers correctly. But a second period would just basically take, start here and add another period, which was pi, in terms of sixths, 6 over 6. So I'd add another 6 pi over 6 this way. That means you'd end up at 11 pi over 6 over here. Remember the period is right here, which is 6 over 6, 6 right here, like this, 6 pi over 6. So if I add these two here together, that gets me to another period. But I'll just stop right here at 1 period, and you make a nice little curvy thing, a little off on that one, and then you're done. Okay, so that's sine and cosine, the two biggies. Now, tangent and cotangent are going to be next, and secant and cosecant will be last. Sine and tangent, cotangent, they're the easy two, in my opinion, the easy two. This took some time to develop just the graph itself. Okay, when I look at this, well, it goes on forever, by the way. These are asymptotes. This would be an asymptote. If you thought about your homework you're doing in probably 2 and 3 and 4, those two sections, when it said, hey, find the tangent, evaluate tangent of pi over 2. Let's see if that's right. Yeah, evaluate tangent of pi over 2, y over x. That would be 1 over 0, which is undefined. Any place where it's undefined, the graph has a vertical asymptote. That's why it looks like this. And then cotangent would be 0 and pi and 2 pi and negative pi. That's where it's undefined, because it's the flip-flop of the tangent. So you need to have a 0 in the denominator. That means, let's see, y over x for tangent, x over y. The y would have to be 0 for it to be undefined. How many periods here do you think? Right here at cotangent, how many periods? 1, 2. Remember, they're copies. 3, 4. Leah's saying 4. Stop right there. 5, 6. I don't know. Okay, there's what, 8 letters of the alphabet on a multiple choice. 1 to 8, and then the extra one is there's 9, and I don't know. Yeah, so Leah's right. There's 4 periods. Okay, how about this one? How many periods on this one? What do you think, Leah? You're the only one that's giving me a, well, I can't see everybody in the class. Okay, she's saying 5. Okay, I think. So I'm going to say not quite. So I think you'd see these are copies, right? So 1, 2, 3, and these are halves. So put this together, it's another one. So these are together. This would be 1 period, 2, 3, 4. It's like if you slid this over there and matched it up. This has 4 periods shown. 4 periods shown. 4. And the range is all real numbers on both of them, the range. These are little parabolic thingy-jiggies, and I'll show you what those look like at the end of class today. So anyway, going over here, same picture. It feels like the A, B, C, and D. It's true in terms of the transformations. You always still go left, right, and then reflect, and then maybe shrink and stretch. So it's all the same, and then up and down at the end. Here's the thing that's different, though. Period is different. It's not 2 pi over b, it's pi over b. Here, I'll show you over here. Right here. What's the distance between here or between here? That period is pi. The distance right here is pi. Distance between negative pi over 2 and pi over 2 is pi. So it changes depending on what the numerical coefficient is in front of the x. So pi over b And what you'll do on the left and right is bx minus c. This is what I do. That's what I do. That's your left, that's your right, but you're making pi over 2's, which are the asymptotes. The left and right are asymptotes. Did I say that? Yeah. Asymptotes. And only need 3 key, not really points, values. Let's say values. Okay, now I've changed my wording. Instead of points, I made them values. Your left and right are 2 of these, but they're asymptotes. So what you do is you're gonna go something like this. Okay, here's one of them, and here's the other one. Those are the left and the right. The other one of the 3 is going to cause it to be the x-intercept. So halfway in between, it'll always work this way. Halfway in between is going to be an x-intercept. And then you just have to decide, is it rising? See, here's rising. That's a tangent, rising. Unless it's a reflection, you know how to find unless the a is a negative, then it's upside down. But it'll always look this way if there's no negative in front of the a. And then you're done. And you have to say, how many periods does he want? So let's do this one with a different piece of paper. Okay, amplitude, AMP. Amplitude is 2. Period is equal to pi divided by b. And here's my b. So pi divided by 3. Left, this is your left asymptote, ASYMPTOTE, left asymptote, would be this bx minus c. Okay, I'll write that out again. Bx minus c is equal to negative pi over 2. 0 and 2 pi was for sine and cosine, but not for tangent. Tangent's negative pi over 2 and pi over 2. So keep that in mind. Okay, so I'm going to go 3x equals negative pi over 2. X is equal to negative pi over 2 times a third. Because if you divide by 3, it's the same as multiplying by a third. X is equal to minus pi over 6. So this is my left asymptote. Okay, my right. Same b, x minus c, but it's going to be a pi over 2, positive, for the right. And then we go back to 3x again, is equal to pi over 2, divide by 3, pi over 6. And the distance between here the distance equals the period. Oh, our period was pi over 3 up here. Look at, you got going from here to 0, negative pi over 2 to 0, negative pi over 6 to 0 is 1 pi over 6. And from 0 to pi over 6 is a second pi over 6. Yeah, 2 pi over 6 is a pi over 3. That confirms that the period between the two asymptotes is pi over 3. All right, so then what you do is you go like here, this is your y, this is your x, dot, 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 dot. Okay, now this does not reflect. There's no negative. So the behavior will always be, for a tangent, always increasing. Right here, it'll always be increasing, increasing, increasing. And the x-intercept is going to be halfway in between. So the x-intercept is going to be smack dab right there, and it's going to be increasing. And that's 1 period. That's not very interesting. Let's do 3 periods. That's a little bit more interesting. 3 periods. So if you mark this right here as negative pi over 6, this is 0, and this is pi over 6. Let's go here. Okay, so I got to add a pi over 3. I got to add 2 pi's over 6s to get you back over here. Remember, pi over 3 is your period. So this is 3 pi's over 6s here. And if I went over here and I'm going to the left, that means I'm going to subtract 2 pi's over 6s, or subtract the period of pi over 3. Negative pi over 6 minus 2 pi over 3, excuse me, not minus 2 pi over 6 is minus, yeah, that's the same thing as that. It's minus 3 pi over 6, which you could reduce if you wanted to. And then that marker and that marker. Oh, well, that's an easy one. That's got to be 2 pi over 6 right there. That's 3 pi over 6 one. This one here is 2 pi over 6. This is negative 2 pi over 6. And then you come down again like this. That's 3 periods. Okay, I'll do 1 cotangent. And then I think, because I'm looking at the time, we start at 3, we go to 5:30. I think I'm gonna, first time I've ever done this, I can't finish. I think what I'll do is save secant and cosecant, my instruction for the next go around. I'll add it. I'll start off with that, and I'll combine that on Thursday. So I'm going to do 1 cotangent. So on the homework, I would do sine and cosine 4.5, and then 4.6 do the tangent cotangent. Mess around with those problems. And on Thursday, I'll pick up where I left off to do a secant and cosecant, and then move on to the next 2 sections that I have to do. So I want to do 1 more, and then I want to give you time with whoever you want to hang out with. I will give you through tomorrow. I've had people reach out to me because of power outages. They lost their power yesterday, and they're not sure about today. So I'm just going to keep open the little daily quiz today, because usually I say, yeah, once you leave, you got to make sure you put your answers in. But I'll leave it open. So if you feel like you're still not quite clear and you want to wait to put your answers in for later, I'm okay with that. And I'll just check to see how everybody's doing tomorrow around this time before I close it. Is that clear? The group quiz, yeah, that's not a group quiz. The little daily quiz, those of you who want to stick around and get some feedback from each other, good. If you don't want to, then you're free to leave after I do this one. Well, you're free to leave anytime you want, but I'm going to do a cotangent, then I'll do the breakout rooms.
Is the quiz up on the?
Not yet. I haven't opened it yet. So as soon as I'm done with this cotangent, I will open it up. And then you could either stay and hang out with other people to talk about the problems. You can put your answers in if you feel comfortable, or you can wait till later, or you can leave and do it on your own for the little quiz. And I think there's only 5 problems altogether. It's on 4.1, and I'll take that back. I think there might be, well, I can tell you, I'll show you what the quiz looks like here in a moment. Let me do the cotangent. 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 Now the cotangent, the process is the same, but look at where you set the vertical asymptotes to. It's different because it's undefined at different places. So I'll do the bx minus c, but 0 and pi. But everything else is the same. These fall, these decrease, unless there's a negative in front of the a that makes it flip around. Then it kind of looks like a tangent. And the period is still pi over b, just like tangent. Period, same thing. Okay, let's do. I'll do this one. I was going to do this one. That one's going to look like a tangent at the end. I want it to look like a cotangent. So I'll do this one. And then if you, after class today, if you want me to do this one for anybody who wants to stick around, I'll do that for you. I'll do this one. Oh, amplitude's 3 again. So AMP equals 3. Period, PERIOD equals pi over b. It's pi over. Now this one's a little peculiar. The b is actually 1/3. B equals 1/3. There's a 1 in the top and 3 in the bottom. So it would be 1 over 3. And so you got to remember how to divide by fractions, which is the same as multiplying by the reciprocal, 3 over 1. So 3 pi. The period's 3 pi. The distance from the left asymptote to the right asymptote has to be 3 pi. So speaking of left, you're going to take the, in this case, the x over 3 and set that equal to something. In the right, you take the same x over 3 and set that equal to something. The somethings are different than the tangent. Left, right, left, right, left, right, left, right, left, right. Okay, 0 and pi. Yeah, 0 and pi. 0 and pi, 0 and pi, 0 pi. So 0 here, pi there. Okay, multiply by 3, sure, get 0. Multiply by 3, 3 pi. Oh, hey, the distance between us, 3 pi. Check, period. I'll do 1 period, 1 period. So let's see, I need 0, sure. I need 3 pi, okay. This is an asymptote right here. Asymptote. Halfway in between's same thing as an x-intercept. So it behaves the same way for the x-intercept, halfway in between. But because this is a tangent, it doesn't go this way. That's a tangent, and there's no reflection. So it has to fall like this. And you can check it out. Here's an idea. I'm saying if you got really close to 0, the function's value is going to be close to infinity, close to 0 as a radian. How about 0.1? I'll just do this for you. What if I go up here and do cotangent and put 0.1 up there? That's y equals 3 cotangent of 0.1 divided by 3. Let's divide by 3. Okay, Jeff, how are you going to do that? Yeah, it gets really ugly on calculators. So you have to go like this. 3 times 1 over tangent of 0.1 divided by 3. I just take the reciprocal of cotangent's tangent, and then I got a tangent button in my calculator. It's just messy. Okay, put that in my calculator. Oh, 3 goes in the numerator. Okay, let's see. So fraction, put a 3 there. Down below, put a tangent. Fraction again. A 0.1 and a 3 down below. Close that up. Keep my fingers crossed. Whoa, yeah, see, that's what I expected. Remember I said the y value is approaching infinity on that side. 90. Yeah, get really close to here. It's way up here at 90. So it feels like it's doing the right thing. That's 1 period. All right. tired. That's a lot of talking for me. 2 hours straight. Wow. Whew, and I got another class in a half hour. So there you go. I want to stop that sharing. I want to go in and open up your little quizzy thing. For 6. Let's see if this is right. Oh yeah. Okay. It looks like you're going to have 10 problems, 1 point each. Yep. They look like problems out of 4, 1, and 2, just like I said. So I need to open that up, publish that for you like that. And I need to see if anybody can thumb up me. Thumbs up, I see it. It's number 6. Anybody see? It's daily quiz number 6.
It's there.
Jonathan, Morgan, thank you. All right, now, so let's do this before I do breakout rooms for the last, looks like 15, 20 minutes. And remember, I'm not going to turn this thing off. It'll just still be there later on. If you feel like you just want to leave and done, then bye. Otherwise, stick around and I'll make breakout rooms for whoever stays around. So if you're leaving, see you later. If you're staying, that's great. And then I'm going to turn off my Zoom meeting at 5:30 because I got another meeting or class at 5:30. So if you're leaving, see you later. Thanks for coming.
Just to be clear, this is, do we take a photo of our work on this one or
No,
just the answers?
just the answers. It's multiple choice, just like the test. Okay.
Right.
Yeah, no work to be shown on this one, just the answers. Hopefully they're all right. Okay, so it looks like Jonathan's sticking around, yes? Okay, Leah, you're sticking around? Okay, Melissa, sticking around? Thank you. Xenia, excuse me, yes. Jacob, you sticking around? Nope, okay. Delia is Alexia, are you gonna stick around? No, yes, maybe, you're here. Sam?
Yes.
Okay, Alexia is, okay, Sam?
Yes,
Sticking around?
Sam.
Victoria. Thank you. And Catalina. Sticking around? Want to make sure I don't give a couple people that are not sticking around. Okay, Catalina. Okay, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'll make 2 groups. And that way if Catalina's gone. Okay, there you go. I'll still make 2 groups. Here we go.